It's a long way to the top if you wanna rock and roll. Famously sung by AC/DC. One of my favorite get up in the morning songs. And actually you can have both today. You can have both today here on our booth at the Hannover Messe in Hall 9 FO6. Rock and roll is in the evening. There we have our booth party. It's the 20th anniversary. Everybody can come, a big party, a lot of rock and roll and a lot of jumping, a lot of dancing and a lot of fun. So please feel invited, come around. But actually before that, right now, you can have AC/DC. And with this, I would like to introduce the topic for today's live and interactive show, which is electrical energy systems. They are everywhere, in machines, in grids, in shop floors. Everything is an electrical energy system, and we think that we have some quite interesting products for measuring, for analyzing, for communicating those data which you need to understand energy grids. And with this, I would like to start the day, and I'm trying to search for my colleague Roland. By the way, if you have any questions today, you can ask us in the chat or you can write us an email at meet@beckhoff.com to have your own appointment with one of our colleagues. But first and foremost, we need to dig into some hardware, and one of our biggest portfolios is the I/O portfolio. So have fun, Roland.
This is true, because we are not on the highway to hell, because we can measure energy professionally and make sure that everything is up and running. Now, when we talk about measuring energy, we immediately talk about our I/O system. And if you take a look around here, these are all terminals who measure different signals, different currents, voltages, or analog signals, whatever you name it. But this is only 1/3 of the total program. So I need Fabian to help me. Good morning, Fabian.
Good morning, Roland.
Out of this portfolio, there's a huge range of different terminals for power measurement.
Correct.
So why do we have even a variation for power measurement?
Good question. So the problem is, or the good thing with us is, it depends on the customer, what he's needing. Maybe some customers only want to do energy management. Management purposes usually are rather slow. So 10-second update time is totally enough for them. So this is our management group. We have a second group, the measurement group. This is for our standard machinery customers. They usually want to measure way faster and maybe even optimize regulations on that. So then they need milliseconds, and then they can optimize their processes with it. And some of our customers even want to go faster than that. They need microsecond precision in the timing and really want to see the AC current and voltage going up and down and see the instantaneous values, and they then go for our monitoring group, use our oversampling technology, and then they really see every single detail of voltage and current and energy.
So during this week, we talk about price and cost optimized products. This is basically really an answer, because you take exact the function, the feature, according to your requirements, either very sophisticated in microseconds, standard millisecond, or all the way up to just a few seconds, and write one terminal according to the demand.
Exactly.
So every machine user basically can do that. And I think you told me up front, every machine builder even should do this as well to measure the energy.
A very good point. Energy is getting more and more cost intensive. Everything which is costly, you want to optimize. And when you want to start with optimizing a process or an energy application, then you need to measure it first. And that is something really everyone can do. Doesn't matter if it's a machine or a house or a plant, whatever consumes energy should be optimized. And so I hope in every machine we sell, in the final end, we should have an energy measuring terminal.
Now, energy, power is, from a physical point of view, current by voltage. Very simple. I think we learned this in the physics already at school. Now, I looked it up, and you even have some terminals where we, of course, measure current, but we don't measure voltage anymore. So how can I get power with that?
Good question. So
it's not an April 1st surprise. It's a real question.
Yeah, well, true. So this is called distributed power measurement system. So why is it distributed? Because we separate the voltage measurement from the current measurement. So obviously, as you said, we need the voltage information. So we do that once in the system, and then we can transfer this digital information of the voltage to a different terminal. But now, take care, if you have two different measurements and you want to multiply them with each other, you need to be sure that the moment in time is the same one when they were taken.
Yeah.
Because if you multiply two different time domains, then it doesn't work. So, since we're using EtherCAT, we have our distributed clock system inside EtherCAT, and that takes care about that. So EtherCAT synchronizes all the devices, and then we can be sure that the measurements, even though they are separated, were taken at the same time, and then we can multiply the digital U information, voltage, with the physically measured current and get our voltage, power, energy, and harmonics, even though the single terminal don't have any voltage information.
So speed matters, so EtherCAT performance is also helpful for this, because with the distributed clock system, it's easy to do this. Now, this is one thing, the voltage. Other thing is the current. Now, current can differentiate from a few milliamp to hundreds and thousands of amps, and I think we also have a special program of components to connect the current into the terminals.
Exactly. So our current measurement abilities inside the terminal going from 1 amp to 5 amp to 10 amps in the maximum, but 10 amps is way too less for most applications. So you need to transfer big currents into small currents, and that is a current transformer. And obviously, we also want to serve our customers with more or less everything they need for an energy application, and then they need current transformers. They get them from us from 1 amp starting up to 5,000 amps, also in different accuracy classes. Maybe class 3 is enough, but maybe you want to be very precise and go for 0.5. Or maybe you have an old application you want to retrofit, then you need split core devices, because the primary conductor should not be opened again, so the transformer needs to be opened. No problem, we have them in two different versions, in big and small. And for new applications, you should use probably ring type transformers, because they are a little bit cheaper, or you get more acquisition with less money, and for new application it doesn't matter. So then I would always emphasize to go for a ring type, and that's all we can offer. So it's a one-stop market, hopefully, for our customers.
So we don't sell the energy, but everything around to measure it.
Exactly.
Now, thanks for the first insight. I think now, finally, we take the data which are in our EtherCAT system, and we will transfer them just over to the other side of our booth. And Felix, what do we do with our power measurement information now?
Well, first we need to have a very short look at a small machine. So imagine this industrial 4.0 machine. Everything is interconnected. You have transformed this machine into an energy measurement device with click-on current transformers for the motors, for the XTS system, for the drilling station. And now you have got all your data in the PC. And then the big question is, what do we actually do with it? And for this, I have asked Niels to join me, and luckily he said yes. So I feel very honored to discuss with you now our options within the TwinCAT power function. So what actually can I do once the data is available at the PC with it?
Yeah, the TwinCAT power functions allow to acquire all the computed values from the EL3475 terminals, but also take the instantaneous values from the EL3775 terminals and compute the same effective values, harmonics and so on, and offer them both in a standardized and structured interface for further computations.
Okay, so I get raw data and then it's processed a little bit, so I understood it's more or less like a PLC function block, right?
Well, no, your programming skills are not necessary here, because they are ready-to-use modules. You can easily add to the configuration and make use of its functionality and combine it easily together.
Okay. If I would have to compare it then, so it's like a standardized interface. It looks like an Axis interface, right?
Exactly. We want to offer here a very easy-to-use mechanism to configure easy measurement applications, especially in this power systems industry.
Okay. So you can already see what's going on without doing any kind of programming work. What specific applications can we actually implement with the power function? So is it just, let's say, power consumption which we can do, or is there actually more to it?
Yeah, as I already initially mentioned, it's power consumption of machines or special actuators, but it's also power production on a PV plant or other power plants like wind farms, but even down to distribution grids where you have substations or transformer stations where you can easily measure then all the feeders to different consumers and producers.
Okay. So it's actually a tool which I can use even if I'm in traditional machine automation, but it's also helpful if I'm really trying to control, for example, a small local grid or even a bigger local grid, but also if you are operating a wind farm or something like this.
You are right, and we are even offering more functionalities here. So it's very common to have special measurement equipment like a phasor measurement unit. And this is also possible with our functions now to use our modular hardware together with the modular software to make an easy-to-use phasor measurement unit.
And I think it's very important to have in mind that it is all integrated with our standard TwinCAT functionalities. Yeah. So the last question is almost obvious then. If I have the data, if I made the right calculations, how do I transport it maybe to my brain of the energy grid, maybe my cloud device where I'm gathering all the information, where I'm doing further calculations?
Yeah, you're very right. We have a lot of TwinCAT functionalities we can easily combine with the TwinCAT power functions. So there are the communication interfaces to grid utilities, like the IEC 6870, but also the IEC 61850. We have interfaces to the industry, like OPC UA or Modbus. But we can also communicate with cloud systems by MQTT or HTTP, even by SQL to databases, and for sure to our own TwinCAT Analytics.
Ah, okay, and that's the perfect transition. Thank you very much, Niels. I would like to hand over now to Roland and Pascal, who talk about displaying data and further analysis.
Now it seems to be no live and interactive day without a standard. Yesterday we talked about MTP 2.0. Now we talk about the IEC 6870, which Niels just mentioned. And in order to talk about this new communication standard, IEC 6870, I invited Pascal. Good morning, Pascal.
Hi, good morning, Roland.
Younger than ever, my dear friend.
Oh, thank you. Thank you so
Now,
much.
let's dig into this. So what is this all about, the standard IEC 6870?
Yes, it is standard. It's a little bit older, but it is very useful for the communication between a control station, a substation, and an energy system. And we have experience with this communication standard since 2004, so a very long time.
Really long time.
Yeah. And later on, we developed also a bit newer standard with a complete data model. This is the IEC 61850. And we are very proud that we develop both communication stacks by our own, so we have really deep knowledge in-house. And yeah, from time to time we extend also our products from exhibition to exhibition,
yes.
I would say, yes. And so it is new that we have for the 6870 a graphical configurator. And in this graphical configurator, we can define all our data type points, general integration, the different groups. So in monitor and command direction, everything what is necessary for this kind of communication. And by one click, we can generate PLC code of it. It is really transparent. And so you can start up from this point your specific application. And this allowed you to reduce your engineering costs massively.
So you don't program anymore, you just get the code generated automatically and you just control basically the code?
Yes, that's correct.
This is what we showed yesterday on the big picture with the TwinCAT co-agent. So this is almost a function like the co-agent, right?
Yeah, more or less. So I would say we developed already the basement to deal with, with an agent, and this kind of agent we will develop in the future, which is then specifically for the telecontrol stuff in TwinCAT. And then we have the perfect basement with our current developments here, and then it fits together in this co-agent philosophy, right?
Now we got all the data available.
Yeah.
From everywhere, automatically generated code or manual, doesn't matter. Now I think I would like to dig into your core competence, which is TwinCAT Analytics. So now, what do we do with the data in terms of analytics?
Yes, that's true, Roland. I think TwinCAT Analytics can be a key factor for all the energy industry because we need a platform for analyzing the data, right? And this we do also in a configurator, in a graphical editor. And this graphical editor works so that we can take all our power monitoring algorithms to make harmonic analysis, grid analysis, quality analysis of the grid, RMS value calculation. We can take these blocks and put them together. We connect them to build up our own analysis changes. And then we can map this also to our I/O terminals. So a user of TwinCAT Analytics can focus really on this tool. This is really easy to handle because you have to do nothing with programming, just configuration, map to your I/Os, generate again PLC code and something more maybe.
And then you get a wonderful dashboard which actually shows everything.
That is the point.
We're using this also actually in our plant to monitor and analyze our energy consumption.
Exactly. Analytics can generate these dashboards and then we can show in a graphical way the energy consumption.
Well, you know what, let's show it because there's a small video.
Yes, I have the video with me.
Let's start the video and you keep talking.
Okay, cool. Now, we can see here that we can monitor all the different energy values and make the cost calculations of the energy, CO2 emissions we can display, and we can display also historical data. So we can load historical data and work also with the live data in our headquarters in Ferl, and there we built up our own energy monitoring system, and therefore analytics fits perfectly because we can generate not only the PLC code automatically, we generate also this dashboard, what you have saw now in the video, completely automatically without programming. Makes engineering easy.
Yes, perfect use case, and engineering should be easy, right?
Yes, you're right.
Thanks for the insight, Pascal.
Yeah, you're very welcome.
Now we need even more insights, and that's why we invited actually a guest all the way from Sweden. So Felix, give me some insights about this Swedish application.
And not from anywhere in Sweden, from beautiful Lund, where I had the pleasure to study for a year. It was a wonderful year for me. So I'm really, really delighted that you are joining us, Rickard, from the company DLab. Now we have learned a lot about measuring data, about communicating it. And you told me yesterday over dinner that what you are doing is actually grid monitoring. Can you explain us a little bit why this is necessary, why this is important?
I would turn around. Why isn't it necessary?
Okay.
I mean, today in the green transition that we're in, I mean, the power grid is really in the epicenter of this green energy transition, making it possible. Adding more EVs, adding more renewable energy sources, micro-production, big thing also here in Germany.
Yeah.
All this, of course, puts a lot more stress on the power grid than earlier days when we maybe had a big generating source and we had power grid and consuming it, and now everything is going back and forth in a way that it didn't used to before.
Okay, we need to be able to switch on and off the participants of the grid intelligently, and now I think your basic value proposition which you make to your customers is that with your software the uptime of a grid is increased. How you do that?
So by measuring with high resolution, we find small anomalies, small things that are going wrong or about to go wrong on the power grid.
Okay.
So we can find the small deviations, alerting the customer that something is about to go wrong.
Yeah.
They can rectify it before they have an outage. Typically failing components, vegetation, etc.
Yeah. Yesterday you told me about a project in Finland, and when I think about Finland, I think it's huge, and that put things really into perspective for me. Maybe you could talk about a little bit about that again.
Yes, of course. I mean, it's long distances, a lot of cables. So in this case, it was in the western part of Finland, and where we were able to measure and identify a problem before the customer even knew about it. So in this case, it was a faulty switch disconnector out in the grid. So that was malfunctioning. And hadn't we found it and hadn't they exchanged it before, they would have had an outage, would have caused power outage for about 1,000 customers. And a lot of faulty equipment in the grid, which would have led to a lot of extra costs for the customer in this case.
Yeah, it's really, really a completely different sport if you exchange a malfunctional component in an electrical grid. So when we are in classical machine automation, a drive fails, you go into the cabinet, open the cabinet, exchange the drive, half an hour later or 10 minutes later, you are good to go again. If you have to take the car for 5 hours, that's a different story.
It is.
So a lot of measurement points enable you to do some kind of predictive maintenance, give you a lot of insights, so you have a big, powerful grid brain with your software. We always like to compare everything to mammals when it comes to automation. How do we actually feed your brain?
So in our system, the CX from Beckhoff is the heart of it, which is then collecting data from all the outgoing feeders, all the outgoing cables in primarily the primary substations. measuring also voltages and other key components, and then we do this more than 20,000 times a second, compiling all this data locally, shipping it off to the cloud, and there we do analysis, and then we present to the customer what we call actionable data.
Yeah.
So data that they can take action on, be proactive, and actually avoid outages, and also do load flow analysis and load forecasting, etc.
Okay, a lot of many distributed data gathering agents all around the grid.
Exactly.
May I ask you, why did you actually go with Beckhoff Automation for that task?
So we realized early on that we are a software company, and we are fairly good at doing that, developing software, doing the analytics, doing the presentation, but hardware is not our thing, and there are very good companies out there, such as Beckhoff, who have very good hardware. They make sure that it's always up to standard, always up to par, they always meet the requirements, they take the product management responsibility, and that's something that we can leave out and focus on our core business, which is the analysis and the software and the actionable data that we can present to our customers. So it's quite cool actually that we've been working together since 2013, and during those years we have done thousands of installations and measurement points and not one single failure in all that time. So great job by you guys.
I'm pretty sure that will go down, especially Fabian's throat, like warm milk with honey.
I hope so.
Thank you very much, Rickard. I know that you're also meeting some customers here in Hannover, so it really is an international trade show. Good luck for that, and see you later. Probably at the booth party, right?
I will. Thanks for having me.
See you. Now we have a very, very nice ice cup, you could say. We have different versions. We have the icing, but now I would like to have a cherry on top of it. Roland, you are shaking your head.
Yeah, what are you talking about? You start with rock and roll. We're on the highway to hell. Now we're talking about ice cream.
It's both good things, yeah?
Yes,
Rock and roll is good and ice cream is good.
It's perfect. It fits together.
But now let's dig a little bit into hardware before we leave.
I will go back to Fabian.
Thank you, enjoy.
Okay. Now, believe it or not, although we already discussed everything around power measurement earlier today, I think we go back to the roots now and continue with power measurement, because no trade show without a real news.
Ah, yeah.
And if we talk about news, we talk about the EL3475. So what is this all about?
Well, on the first view, you already see it more or less, because the standard terminals have single wire connection, and those ones are obviously completely different.
Right.
So now everything is pluggable. So the current transformer now looks like this with a cable, and you just plug it in, and 3 current transformers are directly connected to your terminal, which makes it way faster than before.
Yeah, but why the hell do you connect an RJ45 to a terminal to measure power? I don't get it.
Yeah, usually these cables are for internet, let's say.
Yeah, or
that way.
Ethernet.
Even better,
Yeah,
yes,
yeah.
right. But in this case, it's not. So here we use 330 millivolt 3 times for 3 current transformers. And then we still have 2 more cores left. These 2 we use for electronic nameplate. This is something really handy for you, because the terminal, as soon as it is connected mechanically to the transformer, can read out what kind of transformer is connected. So in former days, you always need to talk about that. So someone installed the current transformer, said, okay, I used a 100 amp version, and then the programmer need to program that into the terminal. And obviously that can go wrong, maybe. And this is gone now. Yeah, now you just connect that to each other. And by the way, there's one other big change. Whoever did that before knows that this is difficult when you do use a current interface, like 1 or 5 amp transformers, like all the other transformers. Because these transformers also need something to shorten the transformer, because the current needs to flow. If the primary current is flowing, then the secondary current also needs to flow. And if that's not possible, the transformer can be damaged. And here, as I said, we're using 330 millivolt. So now we have a voltage interface. And that makes the system way easier, because you can get rid of the shorting terminals, which need to be in between usually.
So even advanced features. Now, if the terminal can read a nameplate, somebody needs to send a nameplate. So where's the nameplate coming from?
The nameplate is part of the current transformer. So this is now the current transformer. And inside this box, there is a small storage which stores the information. What is it? Who built it? And maybe traceability can also be a topic for your customer. And all these informations are stored here and then can be read out from this terminal.
Okay, but that means that only those customers can use the new 3475 terminal who also takes our current converters, or can we somehow connect other infrastructure components as well?
Very good question. Well, the electronic nameplate is something we do.
Yeah.
But if you don't need that, or if you have to use different current transformers because you're somehow forced to, you only need 330 millivolt current transformers, which is a open standard. And here is a different vendor, and you see this connection shows that we directly connect a different vendor to our hardware because we're using this open standard. So it is an open system, so you don't have to use our stuff. But of course you could.
Now, one final thing, because when I deeply looked into the terminal, I see our numbering 3475, but we have also an extension, and there's one version called 0200. So what is the
Correct.
secret about this special version?
So the standard version is for measuring RMS values like voltage, current, powers, even harmonics are in there. But some customers need to dig more into. You remember the monitoring group where you can get the instantaneous values of the AC current going up and down. This is then also part of the dash 0200 version, because then we can do something called with traces, we call traces, and these traces are instantaneous values from all 12 channels, and then you can really dig into every detail of your energy grid and search for errors, or maybe in best case only see everything is just like the way you want it to be.
Well, that's a good closing up. Everything the way it wanted to be. Thank you for the insight, even in this latest, greatest new terminal. So I think you noticed in this last 25 minutes that we really go from the machine all the way into the grid, and we come back to the machine. And coming back is also we come back to Felix, because we would like to come back to a question which actually occurs already yesterday, right?
Yes, exactly. And the question is not about hardware, so we have asked Daniel to join us again. Thank you for that. Daniel, we were asked about the benefits of virtualization and virtual PLC. Maybe a very, very short recap. What is actually virtualization and virtual PLC? We need another microphone, I believe, because you are out of. Let me check.
Let's take this one.
Let's take this one.
We try again.
Yeah, that
Right.
sounds better.
So, from the beginning.
The benefits of virtual PLC again.
Yeah, okay. And what's virtualization in general? So the idea is to abstract hardware resources through software to better utilize these hardware resources in general. It's a very common concept in the IT where you have, for example, data centers in which you already run tasks or services. And the idea of virtual PLC is to also use these hardware resources in data center for certain, maybe often not real-time critical automation tasks. And the benefits you may gain with this is that you have a centralized management of those virtualization tasks. Therefore, you can get a more flexible deployment of these tasks. And you can maybe also reduce your hardware costs in the field by reusing this existing hardware in the data center.
Okay, very short and concise. And again, automation technology is benefiting from the advancement of the IT technology.
Exactly. Still, IT and OT are more and more converging.
But you know what this is? This is the stairway to heaven if we're going to stay in music tunes, right?
It's not AC/DC.
No, it's not AC/DC. I know. There are more bands than AC/DC. Now, there's more to come. So thanks for joining us. Half hour is almost done. We are back tomorrow. Same time, same place, different people and different topics.
Yes.
But we look pretty much forward to welcome you again. Have a wonderful day. And keep in mind, it's April 1st, but everything we talked about is real, okay? Thanks for joining. See you tomorrow.
See you tomorrow.
Bye.
Bye-bye.